This is the solution video to the intermediate puzzle Pop Your Bubble. And Pop Your Bubble is a puzzle which contains a square with a circle and tangent to that circle a semicircle. And the tangency point is shown here in red. And the triangle which is formed by the two square vertices and this tangency point is shown in blue. The question is to prove that this blue triangle in essence is equilateral. So it has three equal sides and three equal angles of 60 degrees. And I'm going to use the approach of Igor Tiger Geometer. A bit faster than him, but it's basically the same idea, and it optimally uses the symmetry which is in here. So let's start as usual by making visible all the points. You should now see the centers of the two circles. And what the nice thing he does is that he uses the symmetry, the reflection symmetry along the diagonal. So of course the square is symmetric if you mirror it in this diagonal, but also the two circles can be mirrored, and let's do that. If I reflect the semicircle in this circle, it exactly fits in over there, because this one fitted in over here. This circle is exactly symmetric with respect to this line, so we can fit in another circle. And I forgot to mention that the puzzle states that the radii of those circles are the same, so that's very important. The radii here are the same, and of course then the radius of this mirrored semicircle is also the same. And now you can also mirror the tangency point. It ends up over there. And now we can draw several segments. What we know is that from the tangent theorem that this and this segments are the same, because they are tangent to one and the same circle. We know, of course, of the square that this one also has the same length. And I can draw the other segment over here, because again of the same tangent theorem, this one also has the same length. And that makes sense because it's also tangent to the full circle, so therefore we have those four segments of equal length. So what we now already have established is that the blue triangle is isoscalous. It has two equal sides. But we did not yet establish that this side is also equal. But that's not very hard to do, because we have that the circles have equal radius. So that means that because they have the tangent to the same point, then we know that these angles three must be the same. And well, you can easily make that plausible. If I draw this one, then we have down here R. That's the radius of the circle, and let's say we have the side length A. So we know that the tangents of the half of the top circle over there is R over A. And we know that all the A's are the same, so that we know, and all the R's are the same, so we know all those small angles are the same. So basically we have that. Well, let's draw those angles. This angle is the same as this angle is the same as this angle. And because they add up, so there are 3 equal angles, they add up to 90 degrees, so therefore they must all be 30 degrees. And indeed it shows that. Let's make only visible the value. Well, it's not very nice, but you show every time it's 30 degrees. So we have 3 30-degree angles over there. But now we know that because the 2 30-degree angles here are the top angle of the blue triangle, so we have a top angle 60 degree, and then it's very easy to show that this one must, these ones are the same because of the isoscalars we just established. So now we know that this one is 60, this one is 60, and this one is 60. So we have established that the blue triangle is indeed equilateral.